we are discussing about the wave motion, and now we are in a position to discuss the standing waves or stationary waves that is produced due to the superposition of wave from two opposite directions. So first we consider that there is a wave which is propagating along the positive x direction, which can be written as A sine capital A sine omega t minus kx. Okay. Another wave we consider that has the same amplitude, same frequency, but same wave number, but propagating in opposite direction. When these two waves will superpose, what will be the structure of the resultant vibration, resultant wave? Okay, that we want to discuss. So first wave is propagating along positive x direction, second wave is propagating along negative x direction. Both have same amplitude, same frequency, same wave number, means their speeds are also same. Then when they will superpose, resultant vibration y will be y1 plus y2, y1 plus y2. So it is simply giving a common sin c plus sin d, that is 2 sin c plus d by 2 into cos c minus d by 2. So it is actually coming 2a cos kx sin omega t, 2a cos kx sin omega t. Okay, the resultant vibration looks like 2a cos kx sin omega t. Now you can think of that this is just like a simple harmonic motion with amplitude 2a cos kx, because simple harmonic motion equation is a sin omega t, a sin omega t plus delta or a sin omega t cos omega t, like this. So we can consider this is just a simple harmonic motion with amplitude 2a cos kx. Now simple harmonic motion means how many particles are moving in a simple harmonic motion? A single particle. So it looks like a single particle is moving for every value of x in a simple harmonic motion. For each and every value of x, we can consider one particle, and that particle is performing simple harmonic motion. Okay? Now see, for different values of x on the string, 2a cos kx will have different value, means the amplitude of the simple harmonic motion is not the same for all x coordinate. So for a particular x coordinate, it has a definite value of amplitude, it cannot go beyond that. The maximum amplitude comes for 2a, where cos kx will be 1, plus 1 or minus 1. Maximum amplitude comes. Minimum amplitude comes when cos kx, this factor will be 0. So we can write here the wave produced will look like this. Like this. See, the particle at this position at certain value of x, this is the x coordinate. So suppose this coordinate, this particle has maximum amplitude of 2a, this one, 2a. But is this particle having magnitude, amplitude 2a? No, it is less than 2a. So at different values of x, the amplitude will be different. All the particles are performing simple harmonic motion. This particle is performing simple harmonic motion, this particle, this particle, this particle, all these particles are vibrating in simple harmonic motion. But their amplitudes are not same. At a fixed point, amplitude is predefined by this factor. Okay. Now, there are some particles which is not at all vibrating. This one, this one, this one, this one. They are not at all vibrating. They have always zero amplitude, zero displacement. Those points are called nodes. Node means no displacement. Clear? Some particles have maximum displacement. Which particles? This one, this one, this one. Because they have maximum amplitude of vibration on either direction, that is 2A. Okay, because this function amplitude will be maximum when cos kx will be maximum, cos kx maximum value will be plus 1. For minus 1 you can also consider the same value in the opposite direction, because cos kx will be minus 1, in that case it will be minus 2. So this particle can move with maximum amplitude. Okay? So this particle is also performing SHL with amplitude 2A. This particle will performing SHL with an amplitude less than 2A. This particle is not at all vibrating. So this point is called node. And maximum amplitude point is called, this is the maximum displacement, that is called anti-nodes. So these points are called nodes. This point is called antinodes. So this is the formation of this stationary wave. Okay. If you have any question, you can ask. Now, from this calculation, now if I ask you, how can you predict from this calculation that the wave is not propagating? Wave is stationary. Yes? Is not there. Means with time the x coordinate is not varying in the argument. Previously, when you were writing the equation of a progressive wave, there is this part sin omega t minus kx. Means you can calculate that dx dt equal to omega by k. Now t is independent. Now x is independent of t. The wave is not at all propagated. That's why this two part, x and t part, is completely separated. Okay. Now, what feeling you have if you produce the stationary wave on a string? You will find that the string will divide it into certain number of loops and entire part will vibrate, and this type of structure you can see. So where each particle is vibrating like this, but nothing is going to propagate. That's why it is called the stationary wave. Now, from this we can find that, see, where is the first position of the node? At this point, then again at this point, again at this point. So what is the distance between two successive nodes? What is the distance between two successive nodes? Lambda by 2. Because if you start from this point, where the wavelength will complete? At this point, see, only one wave, this one. So this one wave will complete. So this distance is equal to lambda. So how many nodes are there between? And another one more node is there between. So distance between two successive nodes is lambda by 2. Distance between two successive antinodes is also lambda by 2. See this distance. That is also lambda by 2. So write down distance between two successive nodes is lambda by 2. Distance between two successive antinodes is also lambda by 2. I use the graphical technique because otherwise from the general solution of cos kx you can also determine this factor, that two nodes are differing by lambda by 2 and two antinodes are differing by lambda by 2 also. But in that case you have to know the general solution. Okay. Now, suppose that this string, there is a string connected between those two ends, and I plug any portion of the string, plug any portion of the string downward and released. A transverse vibration will form, transverse wave will be formed on the string. Now see, from this point a wave is propagating in any direction, then it will be reflected and they will superpose and they will form the stationary pattern. So within a moment you will see that entire string looks vibrating like this in a certain loops similar to this one and producing this stationary wave. Now I want to ask you one question. If it is vibrating in a string, stationary wave is produced, can it happen that it will vibrate in certain number of loops which is in fraction? Can the number of loops be a fraction? Suppose 3.5 loops. Can it be? Because counting cannot be done with decimals. 1 loop, 2 loop, 3, 4, 5, 6, 7, 8, 9, 10. But can it be 3.8 loops? No. Then why the fractional number will not come? Say 3 loops is completed and then 1 loop is not completed, half of the loop is prepared. Can it happen? No. Because at the two ends, definitely there will be nodes, because these are rigidly fixed, and loop will be formed accordingly such that it will be an integer always. Now this is related to the quantization rule. So loop will always be in integer numbers. There should not be any fraction. So this is called the quantization technique that you will also learn in some other chapters. See, now what is the distance between one node and next antinode? Lambda by 4. Because distance between two successive node or successive antinode is lambda by 2. So distance between one node and just next antinode. This will be lambda by 4. Remember this factor always. On this factor we will discuss the organ pipe problem. Open and closed pipe. Only this factor is required. Distance between two successive one node, distance between one node and next antinode is lambda by 4. Lambda by 4. Only this much. Now we can start the organ pipe problem. See. Suppose first we discuss the closed organ pipe. A vibrating tuning fork is held at this point, and as a result inside the organ pipe there is air column and a vibration is going to this air column. If you hold a vibrating tuning fork in front of the open end, then a vibration will be impressed on this air column and this wave will propagate through this. Now when this wave will propagate through this one is a progressive wave. Now this progressive wave will come to this point, and in this case which medium is vibrating? Air medium. Previously when we considered the reflection in the last class, what is vibrating? The string. I take a string connected to that end and producing jerk. So the medium is the material of the string. Now the material is air. So you can think of that air medium's particles are in motion, vibration. Now consider some air particle which is in contact with this closed end. So it is having a solid surface or liquid surface in contact, so which will exert more friction. So the vibration will try to move the air particles, but this air particles at the bottom which is in contact with the solid surface or the liquid surface, that cannot be moved because friction between solid friction given by solid and liquid will be much more than the air. So this air particle will never move. So this air particle will behave just like that rigid bound with the rod. So the wave will reflect it in a manner that crest will be converted to a drop, or compression pulses will be converted to a rarefaction pulse. So this is an example of reflection from rigid boundary. Reflection from rigid boundary. Obeying that rule, the sound wave will reflected from this portion. Clear? Yesterday we discussed reflection from rigid boundary and reflection from movable boundary. So maintaining that this air particle will not at all move from its position and it is reflected. But now this tuning fork is sending the vibration and this is the reflected wave, so they will superpose, and when they will superpose they will produce the stationary wave inside the air column. So air column will be divided into loops and vibrate, because one wave is coming, another wave is reflecting. These are superposing. So their superposition will produce stationary wave that we have seen already. So this, when the stationary wave will be formed, the string will be vibrating in loops. So here instead of string there is air column. So air column will be vibrating in loops. Clear? Now this end there is some air particle also, but this is at the free end exposed to air. So this has a chance to move with maximum amplitude, because in this case if you are going just outside this pipe, there is free air movement and static air has more pressure, but free air, the moving air has less pressure. So that's why this point can move freely with freedom. But this point of air particle cannot move because it is suffering huge friction force because it is contact with the solid or liquid surface. Done? Now, since this air particle can move with maximum amplitude, which type of scenario will form here? Nodes or antinodes? Maximum amplitude means antinodes will be formed at this end and nodes will be formed at this end. So this is the structure of this stationary waveform. This one. Antinode is there, node is there. At the open end, one antinode will be formed. At the closed end, one node will be formed. Okay. Now, we are considering the first mode of vibration. First mode of vibration. So, in first mode of vibration, at the open end there is an antinode and at the closed end there is a node. Now, what is the distance between node and antinode? Lambda by 4. Since it is first mode of vibration, we consider it lambda 0. So, we can write that this gap is actually lambda 0 by 4. So we can write that lambda 0 by 4 will be equal to length of the organ pipe. Distance between node and antinode in terms of wavelength will be lambda by 4. So here, since it is first mode of vibration, we consider lambda naught by 4. Okay. So we consider in this case the wavelength is lambda naught. So that will be equal to length of the pipe. If length of the pipe is L, length of the pipe means length of the air column. Then we know that lambda equal to speed by frequency because V equal to N lambda. So we can write it is 1 by 4 into speed of the wave V divided by frequency. So since it is first mode, it is called the fundamental frequency denoted by N0. Then from this we can write N0 will be equal to V by 4L. N0 equal to V by 4L. So this is the fundamental frequency of a closed organ pipe. Okay. Fundamental frequency of a closed organ pipe. Now, we consider the second mode of vibration. Same pipe. Now, why the second mode of vibration will come? Because these reflections from both ends are occurring again and again. So within short time there is more complicated vibration structure forms. Many loops will be formed because there are multiple number of reflection and multiple number of superpositions. So in the second mode of vibration, whatever be, second mode, third mode, anything, at these two ends, node and antinode will be definitely formed. Open end must be antinode, closed end must be node. Okay. Now in the next mode of vibration, one more node and antinode will be formed in between these two. How? Check. This is the second mode of vibration. This structure will be formed. So more and more loops will be formed. Okay. Now see what is formed. One more node will be formed here. One more antinode will be formed here. So as the mode of vibration increases, one more node and antinodes will be formed in between the pipe, between the two ends. Previously, at the open end, first mode means at the open end there is an antinode, at the closed end there is a node, and no other node and antinode. In the next mode of vibration, second mode, node and antinode will be there at the closed end and open end, but one more node and antinode will be formed in between these two. Okay. Now, each node and antinode is differing by lambda by 4. So now the wavelength is decreased. So we should write lambda 1 by 4. Previously it is considered as lambda 0. Now we consider it lambda 1. But distance between these two gaps then lambda 1 by 4. And how many gaps are there? 1 gap, 2 gap, 3 gap. So it will be L equal to 3 lambda 1 by 4. Previously it is 1 node and antinode, gap is 1. So that is 1 into lambda naught by 4. Now it is how many gaps? 3 gaps. 1 gap, 2 gap, 3 gap. And each gap have a length of lambda 1 by 4. So the wavelength is changed. Okay. Now for this particular case we can write L equal to 3 by 4. What is lambda 1 now? 3 by N1 because frequency is changed. V by N 1. Now you can write N1 equal to 3V by 4L. 3V by 4L. But V by 4L means N naught. So it will be 3 N naught. So V by 4L, so it will be 3 N naught. Similarly, what will be the next frequency? 5 N naught. So 1, 3, 5, 7, all odd order harmonics are only present in closed pipe. Even order harmonics are not present. Okay. So in this way you can consider the more and more complicated modes of vibration. We are considering second mode, then third, fourth, fifth, etc. And you will find that in every step, one node and one antinode will be increased between this pipe. And as a result, since node and antinodes will be more, the wavelength will be shorter and frequency will increase. So first mode of vibration, lowest frequency, V by 4L, then it becomes 3 N naught, then it will be 5 N naught, 7 N naught, 9 N naught, so only odd order harmonics will be present. If we are going to the open organ pipe, then what will happen? Check. Both ends are open, that is called an open organ pipe. So obviously when you put the tuning fork here, at this point there will be a antinode, and at this point there will be antinode, because both ends are exposed to air. So air particle at that point have maximum displacement. So antinodes will be formed at the two ends. But between two successive antinodes there should be at least one minimum number of note, one note should present in first mode of vibration. Then some more complicated vibration we will discuss. See what happens in this case. This vibration looks like this. So one node will be formed in first mode of vibration. Okay. Now you can calculate this one. That is, how many gaps are there between nodes and antinodes? 1, 2. So it will be L equal to 2 into lambda naught by 4. Lambda naught by 4, lambda naught by 4. And how many gaps? 2 gaps. So 2 into lambda naught by 4, that will be equal to entire length of the organ pipe. Okay. Then N equal to, then lambda naught means V by N0 into 2, 2 and 4, which will be 2. So N0 will be equal to V by 2L. That is the first mode of vibration or fundamental frequency. Okay. Now we are going to the next one, second mode of vibration. What will happen in the second mode of vibration? See, obviously on this side there will be an antinode. There is again antinode. Now it will be more complicated. See, node, antinode, node. See, previously there is only one antinode inside the pipe, one node inside the pipe. Now one more antinode and node will be produced. Whenever you are going to higher mode of vibration, one more node and antinodes will be produced. Remember this one. Now, how many gaps? 1, 2, 3, 4. 4 gaps are there. Between node and antinode, this gap will be 4. Now, so wavelength we can consider now to be lambda 1. So it will be lambda 1 by 4 into 4. Each gap is lambda 1 by 4, lambda 1 by 4, lambda 1 by 4, lambda 1 by 4, lambda 1 by 4. So there are 4 gaps. So N can be written as 4 into lambda 1 by 4. Now 4 cancel, you can write N equal to lambda 1 means V by N1. So we can write N1 equal to V by L. N1 equal to V by L. Can I write this one as 2V by 2L? Okay. Now what is V by 2L? N0. So it will become 2N0. So next one will be 3N0, 4N0, 5N0. So there is no gap. That means all order multiples are present, even odd both, in open order pipe. Okay, so in closed organ pipe, only odd harmonics are present. In open organ pipe, both harmonics are present, even and odd. Now, I want to ask you one question. That is, which organ pipe sound will be more musical when you hear this sound? Closed or open? Which organ pipe sound will be more musical? See, I will demonstrate two sounds. Just hear and tell me which one looks better or soothing to your ear between these two. It may not be soothing to a very good song, more than soothing to than the song, but still between these two sounds I will produce two different sounds. First one. Okay, next one. Which one? No? The second one. Second one is more rhythmic. First one has no rhythm. Haphazard. First one is haphazard. No rhythm is there. Second one is continuous. So this is rhythmic. Rhythmic sound will be more soothing to the ear. So the singers who have very good quality of singing, they have actually more and more rhythmics. Their vocal cord can produce more and more rhythmic sound. Rhythmic sound means all higher number of harmonics will be produced. So like more harmonics will be there, and who cannot sing. If I want to sing, there will be so many few harmonics will be there, and as a result it cannot sound good. So number of harmonics should be increased such that the musical quality will become good. Now see, in these two pipes, in which the number of harmonics will be more? Obviously open pipe, because odd even both are present. Exactly, we can say that in closed pipe half are present, half number of harmonics are present than the open pipe. So open pipe sound will be much more musical. Can you give me one example which musical instrument uses this technique of open pipe? Flute. Sound of flute is very musical. You can consider the other this type of organ in pipe instrument. Among this, flute will be highest musical quality. So if you consider a closed organ pipe type instrument, it will not be so musical. Okay. Now we will discuss another case of superposition of waves. Suppose I have one progressive wave y1 equal to a sine omega t minus kx. Suppose omega 1 t minus kx, y2 equal to a sine omega 2t minus kx. See, both the waves are propagating along the same direction, that is positive x-axis. These are propagating towards positive x-axis. They have same amplitude, same wave number, means same wavelength, but differ in frequency. Omega is different. Omega 1, omega 2. Now we consider the difference of frequency is very slight, small frequency, because omega 1 minus omega 2 is very small. Okay, so how we can consider? Then we can write as if omega 1 equal to omega plus delta omega, and omega 2 will be just equal to omega. So what is the difference of frequency? Delta omega. Omega, suppose omega is 512 and delta omega is 3. So omega 1 will become 515 Hz and omega 2 will be 512 Hz. So this much, delta omega is very small. Okay. So we consider here, suppose omega 1 is 515, omega 2 is 512. Then what will be your delta omega? 3 Hz. So with respect to 512, 3 is very small. Okay. So we consider this much small delta omega. Now I will try to superpose these two waves. When these two waves will superpose, both are propagating along the same direction, their superposition will bring some resultant wave. I want to calculate that structure of the resultant wave. See, resultant vibration will be y1 plus y2. So you can write a common sine omega 1t minus kx plus sine omega 2t minus kx, right? Omega 2t minus kx. Now use the formula sin c plus d. 2 sin c plus d by 2 into cos c minus d by 2. So right, it will be, a is there, this one will be 2 sin c plus d by 2. This will be omega 1 plus omega 2 into t by 2 minus kx, first term. Second term will be cos omega 1 minus omega 2 into t by 2. This is sin c plus d by 2. This is cos c minus d by 2. I calculate directly. See, when you add c plus d, omega 1t plus omega 2t will come. So t is common. Omega 1 plus omega 2 is there. And minus kx will be minus 2kx. Then c plus d by 2. By 2 means this factor divided by 2 and minus 2kx divided by 2. So minus 2kx divided by 2 will be minus kx. So this factor will become omega 1 plus omega 2 into t by 2. And when you subtract, this kx part will cancel. So omega 1t minus omega 2t. So t common and c minus d by 2. So divided by 2. Okay. Now, so now we can write this one by rearranging. 2a, I will write the cos term first. Cos omega 1 minus omega 2 into t. But what is omega 1 minus omega 2? It will be delta omega. Check. Omega 1 minus omega 2. It will become delta omega. Delta omega t by 2 into sine. What is omega 1 plus omega 2? omega 1 plus omega 2. Check from this. Omega 1 plus omega 2. It is coming 2 omega plus delta omega. So with respect to 2 omega, delta omega is very small. So we can neglect this one. With respect to 2 omega, delta omega is very small, because with respect to omega, delta omega is very small. So with respect to 2 omega, it is almost negligible. So we can neglect it. Then it is approximately equal to 2 omega. Substitute it. There is omega 1 plus omega 2 by 2. So it will be 2 omega by 2, that is omega. So as if the resultant wave structure remains same, only the amplitude is modified. Resultant wave structure is something like sine omega 1 t minus kx. It is almost maintaining same value, sine omega t minus kx. Because delta omega is very small, so we can consider that omega 1 and omega 2 are almost same. So resultant wave pattern will remain, wave structure will remain same, the propagating part. But only the amplitude is now variable. Previously amplitudes are constant. Now after superposition, amplitudes are variable. Previously in stationary wave, amplitude is varying by x. Because in amplitude part there is 2 cos kx. Here in amplitude part t is involved. So variation of amplitude with time will occur now, and that will produce the beat. Previously in stationary wave, variation of amplitude occurs with position x, because in the amplitude part x will be there. Here in amplitude part time will be there. Moreover, in case of stationary wave, this part is free from time. Time is only there. This part is free from x. See, stationary wave equation. There is only sine omega t. Kx is not there. That's why we are saying that this wave is not propagating with time. Here omega t and kx both are there. Means the wave is not stationary. It is propagating with this variable amplitude. Propagating with a variable amplitude. Now amplitude is varying with time. Maintaining a cosine factor. Cosine term will be there. Means this variation is abrupt or periodic. Amplitude will vary with time. Will this variation abruptly, will it vary abruptly or periodically? Periodically, because cosine function is there. Sine and cosine are periodic function. So if there is no such cos function or sine function, then it can vary abruptly. But since there is cosine function and t is related in the argument of cosine function, it will vary periodically. Clear? Now, so when this cos factor will be maximum, what will happen? The amplitude will be maximum, cos factor will be maximum, amplitude will be maximum. When this cos factor will be 0, amplitude will be 0. Now see, when cos kx means cos this part, delta omega t by 2, this one will be plus minus 1. Then what will be the value of the amplitude? Plus minus 2a. When cos delta omega t by 2 will become plus minus 1, then this factor will have an amplitude of plus minus 2a. Okay, means if it is sound wave, you can hear the maximum sound. And when it will be 0, you can hear the minimum sound. So hearing this maximum sound will occur after a regular interval. After a regular interval, you will hear loud sound because of the presence of this cosine factor. So, hearing loud sound after a regular interval, that is called hearing loud sound after a regular interval in this situation is called beats formation. This is the beats formation in the musical instrument or in a musical concert. When they produce beats, you can hear the loud sound after regular interval of time. Okay, so that hearing the loud sound after regular interval of time is called beats. Sound wave is generally propagating, but between them suddenly the amplitude will be larger. That is called beat. Suppose someone is singing, and between that singing sometimes this beat will occur. So the structure looks like this. This one. Original wave is propagating, but between them at some point some bits will be given. Bits will be given. This type of thing will occur. The general sound is there. With that, extra bits will be provided. Now, from this we can actually write when cos theta will be plus minus 1, cos 0 will be 1, cos pi will be 1 or minus 1, cos 2 pi will be plus 1 again. So like this. So we can in general write that this angle delta omega t by 2 should be equal to n pi, where n equal to 0, plus minus 1, plus minus 2 and all this. So n equal to 0 will give you cos 0, n equal to 1 will give you cos pi, n equal to 2 will give you cos 2 pi. So all have value either plus 1 or minus 1. Okay. Now here we consider the nth bit. So nth bit when occurs at the time t. So I should put here one n in suffix such that it is the time of producing nth number of bits. Suppose 5 bits, 6 bits, 7 bits. So this n should vary. T1, T2, T3, T4, T5 like this. So that's why I put one suffix. Then what is omega? 2 pi into frequency f. Omega can be written as 2 pi f. 2 pi f. Okay. Then it can be written as 2 pi delta f, because omega is equal to 2 pi f. So delta omega will be 2 pi into delta f. Because when omega can vary, 2 pi cannot change its value. So when f will change its value, then only omega will change its value. So that's why I write delta omega equal to 2 pi delta f. So this will be into Tn divided by 2. This will become n pi. So this 2 will cancel, pi will cancel. Then from that, can I write that n by Tn equal to delta F n by Tn equal to delta F okay, n by Tn, that is equal to delta F. Now, for hearing two successive loud sound, what will be the value of n? Hearing two successive loud sound, successive, what should be the value of n? First one, write down. Next one, then n should be 1. Because if you put n equal to 2, then it will be one more than other. So two successive sound means n should be 1. So put n equal to 1. So then it will become 1 by T1. So this is the time gap between two successive loud sound. This is called time period of hearing loud sound. Time gap between two successive loud sound means time period of hearing loud sounds, and this is 1 by time period. 1 by time period means frequency. So whose frequency? Frequency of hearing loud sounds. So that is called bit. So it is called the bit frequency. And what is bit frequency? Delta F means the difference of frequency of the interfering waves. So if one is 515, another is 512, then what is the difference of frequency? 3. So bit frequency will be 3 Hz. So from this you know this one, that bit frequency is equal to difference of the frequency of interfering waves. So if there are two interfering waves, one is of 515 Hz, another is of 512 Hz, then their difference will be 3 Hz. So frequency of hearing bits will be 3 Hz. Means in 1 second you can hear 3 loud sounds. 3 times loud sounds will be produced in 1 second. Clear? So that is termed as bit frequency. Same type of problem is, one problem is there. One is n minus 1 frequency, another is n plus 1. 3 sounds are given. What will be the number of bits produced per second? That is in the question paper. So the answer will be highest frequency sound minus lowest frequency sound, calculate the difference between frequency. So n plus 1 is the highest frequency, then minus n minus 1 is there. So what is the difference of frequency? 2 Hz. So how many bits will be produced per second? This is the theory behind that. The bit frequency will be equal to difference of the frequency of interfering waves. Okay. There is one more question of bit also in first paper, mock 1, that is 256 answer will come. 260 is there, it is producing bit with another tuning fork whose first mode of vibration is given, and what will be the frequency of the other tuning fork, that has to be calculated. From this formula you can proceed. Okay? Now, in the other parts, what we have to discuss little bit, other topics. Center of mass. Okay, fine. So center of mass and all these things. Who skipped this topic? Center of mass, rigid body in class 11. Slowly hands are rising. Okay, good. See. So center of mass. See, first when we discussed about the particle mechanics. Particle mechanics means we consider a single particle and we discuss the motion of this particle under the action of forces. Clear? That we have already discussed. We learned about work for energy and all these things, but mostly they are related to the particle mechanics portion that we have done. But if there are many particles in a complicated system, not a single particle, it's a massive body or too many particles are there, then how to apply Newton's law for each particle? Suppose there is a football and we can consider that different parts of the football are not rigidly attached to each other. In that case, or even if you consider a very stable object like this table or these things, its motion we have to consider. Many particles are there. Then one method is that for each and every particle, whatever be the external force acting, I will find that and calculate the force on each and every particle to describe the motion of each and every particle, and then we will calculate the resultant velocity. That is possible theoretically, but practically not at all possible. Because if I want to find the whatever be the number of particles in this table, the counting will never end. Then we have to calculate the force on each and every particle. That will never end till I die. Till I die. Because there are enormous number of particles. Okay. So for this reason, we will not consider this entire system to a particle of this system individually. I want to calculate the aggregate behavior as a whole. Now, there are two procedures to introducing the concept of center of mass. Firstly, by considering a similarity between center of mass and center of gravity at the beginning level for the small objects whose dimensions are not so large compared to the dimension of the earth. Okay. So suppose Himalaya mountain, Alps mountain, etc. All these, you cannot consider that their size is negligible compared to the size of earth. They have significant size compared to the size of earth. But for this marker, for apple, for this building, I can consider that their dimensions are very small compared to the dimension of earth, and we can consider that for these small objects, center of mass and center of gravity are same point. That's why we can consider the concept of a balanced point. Concept of a balanced point as the center of gravity or center of mass. Clear? First, what we will do, I will take this book and I want to find its center of mass. Normally speaking, its center of mass finding is not difficult. I can consider this point and this point, draw the diagonal, and the intersection point of the diagonal will be its center of mass and center of gravity both. But remember, who told you that mass of this book is uniformly distributed? This side there is a binding, this side there is no binding. So mass is not uniformly distributed. So how can you predict that center of mass is exactly at this intersection point of the two diagonals of the front page? Even the thickness of the pages may vary, because this cover has more thickness than these loose pages. Okay, so truly speaking, if it is completely ideal case, that is mass is uniformly distributed, then it is definitely at this center. Okay, but if it is not uniformly distributed, or even it is not in a proper shape, it may be any odd shape. Suppose using a scissor I can cut these portions anywhere. So for that odd shaped object, how to determine the center of mass or center of gravity? See, first you have to hang this book with respect to any position. Suppose this one like this. First I want to put it like this, but it will not stay in this situation. Whenever I release, this will be. So in this way it can stay. Why? Because if I try to put this one, it is not staying at this. If I want to put it only by holding this much, I cannot. It will be always like this and it will stop. First it will rotate small amount, then stop. Means the line of weight vector must pass below this point about which it is hanged. Line of the weight must pass below this line, below this point of hanging. Okay, fine. So from this point in the direction of gravity, just draw a straight line. Just draw a straight line. Straight. Because earth, the gravity is downward, so in the downward direction from this point just draw a straight line. Then again hang this book with respect to any other point as you wish. Suppose this one. And from this point again draw another line in the direction of gravity. These two lines will definitely cut at some point. These two lines on this page will definitely intersect at some point, and that point is the center of gravity. And since this is a small object, we can claim that this is center of mass. Clear? Okay? No or yes? Yes. Okay. Now, with respect to the center of mass point, if you apply only one finger to hold it, then if it is properly center of mass, then you can hold it horizontally. That's why it is termed as balanced point. Okay. Now for the massive body, this method will not work because center of gravity will be different. Then we have to go for a general procedure. Now, this is the very basic idea of the center of mass. Now think about it. In a collision problem, when we discuss a collision problem or anything, what we have done? Suppose this one is a mass M2, this one is another mass M1. M1 is rushing towards M2. Suppose M2 is also moving or not moving. It is moving. Collide. After collision, we consider elastic collision. After collision, this M2 is moving with a velocity v2, M1 is moving with velocity v1, and you immediately jump to write the equation M1 v1 plus M2 v2 equal to M1 u1 plus M2 u2. Clear? Now, if I say that during the collision each body is exerting a force on each other, and the nature of the force is acting for a very small time and its magnitude is very large, so that is an impulsive force, and impulsive forces are very notorious. Impulsive forces are very notorious. Why? You cannot calculate acceleration for the impulsive force. You cannot measure acceleration for the impulsive force. Why?
Time duration.
Because time duration is very less. Then why impulsive force is named so? Impulsive. Okay, I will show you one example. Come. See. Suppose I apply certain force on his body. Okay? Like this. Until like this. Okay? So one time will come, he will feel some pain, and as he is feeling more and more pain, suppose he is shouting, but the sound of the shouting will increase slowly. First it is small, so it will be higher than. So this is like velocity is increasing. Velocity is increasing but slowly. So you can measure the delta V by delta T properly. You have the time. Now suppose I do a separate thing. I apply the same force, but all of a sudden slap. But you will first he is shocked. Slap me. And after some time he realized the slap is so strong that I have to shout. So initially the sound is stopped, suddenly it outburst. So the same thing happens to the impulsive force. So whenever this particle is moving with a certain velocity, you are applying a force, this is increasing. So proper triangle will be formed and you can measure delta V and delta T and changing velocity by changing time to measure the slope and acceleration. But if you are giving impulsive force, this is the velocity, abruptly jumps. You cannot have that time to measure the acceleration, and even acceleration is not there. Velocity is u, suddenly it jumps to v and again constant. That is the case of an impulsive force. Means the nature of the impulsive force, if I want to write in a mathematical form, it is very complicated. Because we don't know the acceleration or anything, how can we write the mathematical form? Then you are claiming that in this problem, the structure of the impulsive force is not required in this collision problem. What we have done before collision, when there is no impulsive force, I write the total momentum m1u1 plus m2u2 in a vector form, suppose. Then after collision, I write it m1v1 plus m2v2 in the vector form and claim both are equal. Means as if this impulsive force is not doing anything to the system. How can you claim that? This impulsive force is very difficult to handle, and now you are explaining that this impulsive force cannot do anything such that momentum initially and finally will remain same. As if something is moving totally unaffected by this impulsive force. Something in the system is moving totally unaffected by the impulsive force. Impulsive force cannot affect it. What is that? That is present in the system. It is moving as if there will be no impulsive force. Means it can completely ignore the impulsive force. Can mass 1 ignore the impulsive force? No, because that's why its velocity is changing. Can mass 2 ignore the impulsive force? No, that's why its velocity is changing. Then which can ignore the impulsive force completely? Center of mass of the system. That's why it is important. So in the entire collision, whatever be happened by this impulsive force to mass m1 and m2, that does not affect the center of mass. Center of mass before collision, if moving with constant velocity, then after collision, center of mass is still moving with the same constant velocity, as if impulsive force is not acting on it. It is completely, it can ignore the impulsive force or external force. So that's why center of mass is important. Because you can completely ignore the idea of impulsive force if you consider the motion of center of mass. Okay? So previously it is moving with a constant velocity. After collision, during collision, no, nothing will happen. After it majestically move with the same velocity. Nothing will change. Okay. Now, in this calculation of the center of mass for a system of particles, first we will just discuss the two particle system and then extend it. Let us consider this is one particle, M1. This is another particle, M2. And suppose we have a origin where the observer is there, and observer is saying that particle M1's position coordinate is R1, position vector, and this one is R2. And these two are line joining them. Okay, fine. We consider in general that M1 and M2 are not equal mass. Now, M1 will attract M2, M2 will attract M1, fine. M1 will attract M2. This force will be along this, and it can be written as F21. That is force on 1, force on 2 due to 1, and it is directed towards M1. Similarly, M2 will also attract M1 with the same equal and opposite force. This can be written as F12 along this. I consider this two particle system. Now, apart from these two particles, there are many other particles in the universe. They can also exert force on M1 as well as on M2. So their effects are considered as a resultant force on M1, that is F1, and on this, suppose they are giving force along this direction, that is F2. Okay. So now you can say, okay, fine. What is the total force on M1? That is F1 vector plus F12 vector. And total force on second mass will be F21 plus F2 vector sum. Now you can say that what is the necessity of taking this force on M1 in two steps? You can also include this F12 within this and write the total external force on M1 and the total external force on M2. I am saying no. Fine. Suppose this two particle system, I consider this 48 particle system. All of you. Suppose one day these two students will fight, exerting force on each other. What will the authority will do? What warden madam will do? Transfer them to the police? Hand over them to the police? Or not? Tell me. Not to the police. And suppose one day some outsider people came and beat him. What warden madam will do? Call the police. Now if I ask, okay, he is also beating him with certain force, outsider also beating him with certain force, now you treat them differently. Can this be a justice? you have to call police in both the cases, hand over outsider to the police, so similarly hand over him to the police. But is it possible? No. That means all of these are the member of the same system, so you can give force on each other, that can be handled separately. But if outsider gives forces, that will be handled separately. So similarly, I consider two particle system, so whatever force M1 and M2 can give on each other, that is handled separately, and the external member can exert forces, that will be handled separately as M1 and M2. Clear? Now we have to use Newton's second law for M1 and M2. I want to write Newton's second law. What it says? Mass into acceleration equal to net force. Net force, but resultant force is mass into acceleration. Okay, fine. For first particle, mass is m1. Acceleration can be written as d2r1 dt2 in this format. d2r1 dt2, double derivative of position is acceleration. That will be equal to f1 plus f12. Okay. M1. Now write the equation for the second mass also, Newton's law. M2 d2r2 dt2 equal to f2 plus f21. Okay. Now add these two equations. M1 d2r1 dt2 plus M2 d2r2 dt2 will be equal to F1 plus F2. I add both the equations. Okay. See how many terms are there on the right side? 2 plus 2, that should be 4, but I write only 2. Why? I write only 2 because these two forces are action and reaction. So according to third law, F12 will be equal to minus F21. So when you add, you will get F12 plus F21. This will become 0. This will become 0. From the third law. But remember one crucial point, action and reaction cannot cancel each other. Action and reaction forces act on different objects, so they cannot cancel each other. But here I do the same thing. Why? See, I will give you one more practical example. See, these two are fighting, and they are fighting just outside this campus. And when they are fighting, some other people, outsiders, beat both of them. Now, what the authority will do? He is saying that I have been beaten by him and I have been beaten by the outsiders. Give me justice for both. He is also arguing the same thing. I have been beaten by him and the outsiders. Give me justice for both. So what the authority or warden will do? She will say, okay, between them whatever happened, we will discuss it later. First, call police and tell about the hooligans who are beating both of you. Okay. So first the outsiders' activity will be judged. Then between them whatever be the problem, that will be sorted later. Not now. First it is more concerned that outsider beating both of you. Clear? So the same thing. Only thing is that only outsider forces are considered. Inside the system, the members are giving force on each other, that is not coming. That means you are not considering action and reaction on the same object. Whenever you are considering the two particles as a system, so you can consider this is a single object, and action and reaction will become internal forces, and internal forces cannot produce any acceleration or anything. That's why you neglect them and putting them zero. This one coming to be zero. So for a single particle, action and reaction is not cancelled because action and reaction do not act on the same object. But when you consider two particles as a single object, then you can forget about that action and reaction, because then these are treated as internal forces, and Newton's law is concerned only with external force, not the internal forces. Clear? So until you are considering the two particles as a system, you cannot neglect this F12 and F21. So that's why I add the two equations to treat the two particles as a system. Clear? Now, from this I will try to make a modification on the left side. Can I write this one? You can write anything. Whatever you wish, you can write. The left side can be written like this: d2 dt2 of m1 r1 plus m2 r2, because masses are constant. For the particles, masses are constant. So if I differentiate this one, m1 will come out, it will be d2 r1 dt2. Then m2 will come out, d2 r2 dt2. Then f1 plus f2 together, they can be summed as a vector sum, like f. It should be external force. So just mention this external. F external. Because f1 is given by outsider, f2 is also given by as a single particle. Both of the particles' mass is added to form a single particle. There is no such particle. I consider it. And write this one as capital M, where capital M is considered as M1 plus M2. Then this external force is acting on this M1 plus M2. Then where should I put this mass M, capital M, such that this same external force acting on it produces the left side of this equation? In some position I have to put this particle d2, say capital R is the position, like this, similar to that side, m1 d2 r1 dt2 plus m2 d2 r2 dt2. So I have to put this particle in a certain position, say R, such that left hand side and right hand side of this equation will be identical. Then what is the value we are searching for? The value of the capital R. Capital R vector we are searching for. Clear? Then we can do the same thing to the right side. mass is also constant. So I can put it inside the derivative because mass is not depending on time. Then what will get? d2 dt2 of m1 r1 plus m2 r2. That is coming to be d2 dt2 of m1. Then we can say that these two parts should be equal. These two parts should be equal. Then we can immediately write m capital R, that is equal to m1 r1 plus m2 r2. Capital M into R will be equal to m1 r1 plus m2 r2. Then what is capital M? m1 plus. So capital R will be m1 r1 plus m2 r2 divided by m1 plus m2. So then this capital R we are searching for is the position vector of center of mass. So I have to consider the two particles as a single particle. Total mass is m1 and m2, m1 plus m2. Where should we put that particle such that the entire system's dynamics will remain same? So it may be here. I consider m1 is more. So it may be here. So this vector is written as capital R. This point is called the center of mass. I consider m1 greater than m2. So center of mass will be more close to m1. It is more towards the heavier mass. If both the masses are equal, it will be exactly at the midpoint. Oh, okay. You can take a break. Not more than 10 minutes. Many particles are there. It will sound. তিনটা হ্যাঁ কত তো মনে করতে পারি yes that I have used if external equal to m d2 and d2 second one third one is there so 1 equal to minus m mass into acceleration d2 and d2 is the acceleration and impulsion force versus power for every action is always equal and given the action their net force will be zero. Yes, net force will be zero if you are considering the entire particle as a system. Now, from this, if there are many particles, I can extend this equation by taking that m1, m3, r3 by m3 and all this. And in general, if there are many particles, suppose n number of particles, I can write it as mi, ri, I equal to 1 to suppose n particles are there, divided by summation mi, I equal to 1 to n, if there are n number of particles. And if the number of particles is so large that n tends to infinity, then individual particle loses the identity. We can consider it as a continuous mass distribution, and then we have to integrate. And in that case, this formula will become integral r square dm divided by integral dm. Sorry, integral r dm by integral dm. Integral r dm divided by integral dm. Then for x coordinate you can write integral x dm by dm. For y coordinate you can write integral y dm by integral dm, like this. So for 3 coordinates you can calculate individually by taking integrations if it is a continuous mass distribution. Okay. But we will not go in that calculation and all these things. Some center of mass you have to remember some particular structure. From the chart you will find that we will emphasize on a particular case, that is required for problem solving, and I see in your the mock papers some questions are there on that particular topic that we will discuss. The derivation and all these things, that results is given in the book, and for NEET the derivations are not required. Okay, now I will mostly emphasize on the two particle system, not the many particle system. Now just erase all these portions, only I need this final result, and from this I will discuss. Discuss this two particle system. So the result for two particle system center of mass is this one, capital R equal to M1 R1 plus M2 R2 by M1 plus M2. Now think about it. Where is the observer? At this point O. Is O some special point? No. Completely arbitrarily I have chosen any point as the position of the origin and put the observer there. Now there are three other points in this problem. Specific things are there. One point is there where we consider the position of the mass M1. One point is there, the position of mass M2, and another point is there, the position of center of mass itself. Now among all these 3 points and any other points, which point should be taken as the origin by the observer such that he can solve the problem easily? Which one will be most easy? Should he stick to his arbitrary choice of origin, that is O? Should he choose M1 as the origin, or M2 as the origin, or center of mass? Among all these points, which point should be taken as the origin for solving the problem with simplicity? Center of mass itself. If the observer sits on the center of mass itself, then what will be the value of this capital R? 0. So immediately you can put 0 over here and write M1 R1 plus M2 R2, that is equal to 0. If the center of mass is taken as the origin, right? If the center of mass is taken at the origin, then capital R will be 0. Then capital R will be 0. You have to put this arrowhead over to maintain it as a null vector. Null vector. Okay. This has the same similarity with 0, but since the left side is a vector, I put an arrowhead over this, which is called 0 vector or null vector. It gives that M1 R1 plus M2 R2, this will become 0. Okay? Now, what M1 R1 is? M1 R1. M1 R1 itself. What is this quantity? No? Mass into distance. Mass into distance. Achha, anything. Tell me, if you calculate force into distance, it is called torque. Torque has another name. Moment of force. Linear momentum, mv, multiplied by r, is called angular momentum. Moment of linear momentum is called angular momentum. So whenever a physical quantity is multiplied by the corresponding distance, we consider it as the moment of that quantity. So R cross F, moment of force, that is called torque. R cross P means mv, moment of linear momentum, that is called angular momentum. So similarly, R cross M, R into M, this product will give you moment of mass termed as mass moment. mass moment. About which point it is taken? Center of mass. Then sum of this mass moment, vector sum of this mass moments is coming to be 0 when the moments of mass is taken about center of mass. But with respect to any other point it is not 0. When R1 is that one, about O, is it 0? No. But as soon as you choose the observation point O as center of mass itself, then the capital R becomes 0 and sum of the mass moments will become 0. This is a theorem. Write down. Theorem of mass moment. Theorem of mass moments. Mass moments. Now, I will state theorem. Write the theorem now. Algebraic sum of mass moments, algebraic sum of mass moments taken about algebraic sum of mass moments taken about center of mass is always 0. Algebraic sum of mass moments taken about center of mass is always 0. Okay? Then, this is the vector form of the equation. Now we can convert it into scalar form. How? M1, R1. Now, which one is now R1? This side. From this one to this one is now R1. This one to this one is now R2. Because this portion is erased, I consider origin is itself the center of mass. Okay. And as soon as after doing this we can write, then R1 in which direction? Negative side. R2 is in so this is the scalar equation. This equation is required for this problem that is given in your mock paper. Two masses are there and it is set as the center of mass. You have to find out the moment of inertia. And this entire length is given L. So I consider this is R1, this is R2, this is center of mass. So first thing is that concept of moment of inertia, we will also discuss this one. M1 R1 square plus M2 R2 square. This is one equation. Then we have two more equations. One is R1 plus R2, that should be equal to L. And since this point is taken as center of mass, then M1 R1 will be equal to M2 R2. And from these two equations we can solve for R1 and R2. Then R1 is coming M2L by M1 plus M2 and R2 is coming M1L by M1 plus M2. And you have to substitute this R1 and R2 here in the equation of moment of inertia to solve that particular problem. It is, I think, in paper 6. Paper 4. So this Since this is center of mass, you can use this mass moment theorem's result, that is m1r1 should be equal to m2r2, provided this point is the center of mass. What about the other part of the rigid body? Rigid body dynamics. For single particle and all these things that we can discuss first. First we will discuss for system of particles, then we will consider the cases of the rigid body little bit. First we consider that this one is axis and some particle is moving about this axis. Some particle is moving about this axis. So this is the location of this particle with respect to this axis, somewhat single mass at a distance r. Then for this rotation it requires a force, but if the line of action of the force passes through this axis, will the particle rotate? No, because force alone cannot produce rotation. You require torque for the rotation. Means line of action of the force on this particle, I consider this one, F. So line of action will pass like this, so the body will start to rotate. I consider rotation in fixed path. Later this can be done, that rotation is not about any fixed axis, that can also be discussed. First I consider an ideal case where rotation is occurring in a fixed path. Somehow it is rotating in an orbit. Now we can consider this angle to be theta, and then we can consider a vector quantity defined by tau as r cross f, producing the rotation. That is called torque, the moment of force. Now what is the direction of that? If you are doing r cross f, then your thumb will show the direction out of the board for the cross product. So its direction will be out of the board. But in this, how we will denote? About this axis, like this. This is the direction of this torque. This is actually out of the board, okay? This is not on the plane of the board. But here in 2D I cannot draw that 3D, that's why I write in this manner. The cross product. If these two are on the plane of the board, then cross product vector will be perpendicularly outward. This is R, this is F, R cross F. So it is outward. So outward I cannot draw here, so that's why I draw in this manner. But remember, this is outward, perpendicular to both R and F. Okay. Now, I will define one more thing. But before that, I will discuss its magnitude. Tau will be equal to Rf sin theta, Rf sin theta. You can also write this one as, say, extend this line of force and from this point drop a perpendicular on this line. This is vector r. So can you say what is the length of this line? See, this angle is theta, so this angle should be theta. This hypotenuse is r. So what is the length of this perpendicular? R sin theta. So that's why normally torque is calculated by force into its perpendicular distance from axis of rotation. So this is the line of action of force and I drop a perpendicular from the axis of rotation on that line. Then this length is r sin theta. Then r sin theta multiplied by f will give you the magnitude of the torque. And direction defined by the right hand rule. Since this angle is theta, this one is theta, this is r, so this part will be r sin theta. This perpendicular from the axis of rotation on the line of action of force, that is r sin theta. Okay. Now, similarly, I will define another quantity called angular momentum L, that is given by r cross linear momentum P. R cross linear momentum P, that is termed as angular momentum. Now I want to differentiate this angular momentum to calculate the rate of change of angular momentum. Okay, so what we will get? dl dt, that can be written as dr dt cross P plus r cross dp dt. Okay, I use the product rule of differentiation, that is dr dt cross P plus r cross dp dt. Now, what is dr dt cross P? What is the value of dr dt cross P? First term. dr dt means V. Okay, fine. V. What is P? mv. M is constant. V. Then r cross. What is dp dt? Force. Rate of change of linear momentum. That is force. It can be written as V cross V. This one is tau. That is r cross F. What is V cross V? 0. Why? V and another V. Angle between them is 0 degree. Sin 0 will come in the cross product. It will become 0. So what we will get from this? dl dt equal to torque. Similar to this relation, dp dt equal to force. It is called the Newton's second law for rotation. Newton's second law for translational motion says that rate of change of linear momentum equal to force, and this in for rotation says that rate of change of angular momentum equal to torque. So force and torque is playing the same role as that of force in case of rotational motion. Force plays the role in translational motion, torque plays the same role in rotational motion. So you can call it the rotational analog of force. Okay. Now, earlier we have studied the linear momentum conservation. That is, if you put external force F equal to 0, then dPdt equal to 0, means P is conserved. That is called linear momentum conservation. And over that you can solve many problems. Similarly, if external torque is 0, then dl dt will be 0 and L will be conserved. That is called angular momentum conservation. Angular momentum conservation. Similar, torque 0 means angular momentum of the system is conserved. Can any one of you say this angular momentum conservation is used in one of the Kepler's law for planetary motion? Which law? Which is actually in Kepler's law. Kepler derived it geometrically, but it is actually a consequence of conservation of angular momentum. Kepler's second law of planetary motion, that radius vector of the planet sweeps out equal area in equal interval of time. That is, rate of change of area is constant. That is a geometrical counterpart of the angular momentum conservation. Okay. Now, I will introduce this concept of moment of inertia in a different manner. Suppose there is an axis and a body is moving about this axis with constant angular speed omega. A body is rotating about this axis with constant angular speed omega. The axis of rotation is fixed. Okay. Then I can consider one particle in this body, say here m1, which is at a distance r1, from this axis, perpendicular distance r1 from the axis. Then this particle will rotate with which angular speed? Omega. Because the particle is in a massive body. So it will also rotate about the axis with angular speed omega, and its motion is along a circular path like this. Okay. I want to calculate its kinetic energy simply by using the formula half mv square. So what will be its kinetic energy? Half into mass into v1 square. Now what is v1? r1 into omega. Because we know that if a particle is moving in a circle, v equal to r omega. So it will be r1 into omega. So at the proper time I will put r omega in place of v. Then there is not only a single particle, we can consider one more particle on this body. So it has some kinetic energy, half m2 v2 square, and in this way if I take the sum, then I will get the entire kinetic energy of this body, because one particle 1, particle 2, particle 3, particle 4, all this, and I can get the entire kinetic energy of this body of its rotation about the fixed axis. Clear? Which one? Dot dot. Oh, kinetic energy. I want to calculate the kinetic energy of each mass. Since they are moving, they have some velocity. So first mass suppose have a velocity v1, second mass having velocity v2. So what is their kinetic energy? Half m1 v1 square plus half m2 v2 square and so on. So total kinetic energy is a scalar quantity. So we will add for all to calculate the entire kinetic energy of the entire body. Okay. Now, so this is the total kinetic energy. Okay. Now, V1 can be written as R1 omega square, V2 is R2 omega square. So write it half M1 R1 square omega square plus half M2 R2 square omega square, like this. Then half can be taken common. Remaining term can be written as M1 R1 square plus M2 R2 square. Then omega square can also be taken common. Okay. Now, think. In case of translational motion, kinetic energy for translation, that is related as half into mass into speed. Ask you one question. Mass is an intrinsic property of matter. Then what about moment of inertia? Is it an intrinsic property of matter or not? Because it plays the same role as that of mass in rotational motion. It is not an intrinsic property, because if you change the axis of rotation, moment of inertia will change. So it cannot be the intrinsic property. Intrinsic property means solely depend on that. No other physical factor or change of origin will not change this one. If you change the origin, axis of axis, or if the observation point, will the mass of the particle change? No. But moment of inertia will change. So though it is playing like a counterpart of mass, but it has not the same property as that of the mass. From the rotational perspective, it is playing the same role. Okay. So this is the concept of moment of inertia. Now, someone is saying, okay, this body has so many particles. This one is a massive body. I want to consider this entire mass of a body as a single particle. Because this body is composed of masses M1, M2, M3, M4, many masses, and different masses are placed at different distance from the axis, R1, R2, R3, R4. I don't have that much time to calculate single masses and their positions, all these things, to calculate the moment of inertia. I want that entire body should be, entire mass of the body should be just like a point mass. I want to consider it like that. Okay. Then considering the entire mass of the body as a point mass, where should I put with respect to the axis? At what distance should I put that mass with respect to the axis, such that this point mass have the same moment of inertia as that of the original body? Then that particular distance from the axis is called radius of gyration. Radius of gyration means this body may composed of many masses. They have different distances from the axis of rotation. I want to concentrate entire mass of the body just like a point mass, and consider that this point mass should be kept at a certain distance, such that this point mass at that single distance can produce the same moment of inertia as that of the entire body. Then that distance of that single point mass is called the radius of gyration. Okay? Now, let us consider this entire mass of the body is capital M, and it should be placed at a distance k from the axis of rotation to produce the same moment of inertia. Then what will be the moment of inertia of this single point mass? mk square. mk square. If this is a point mass placed at a distance k, then its moment of inertia will be mk square. So write it mk square, and that should be equal to, I consider this part, summation mi ri square. Then k will be equal to summation mi ri square by capital M. Capital M is actually summation mi, its root. Capital M means sum of all the masses, that's why I write summation mi. Repeat. See, entire body, many masses, suppose 1 lakh mass, point mass. I consider that entire mass is concentrated just like a point mass, and put it here at a certain distance k, such that this single point mass have the same moment of inertia as that of the entire body. So sum of moment of inertia of all the particles will be equal to moment of inertia of that single particle. So that particle should be placed somewhere. So what will be that distance? That distance is considered as k. So mk square will produce a moment of inertia as that of the moment of inertia of the entire masses. Then k should be the radius of gyration. Okay. You have continuous masses, then you have to put integral r square dm equal to mk square. Same thing. Done? I will show you one example of radius of gyration calculation. Suppose this is a rod, uniform rod of mass m and length l. What will be its moment of inertia about this axis? 1/3 ml square, 1/3 ml square. Moment of inertia about one side. If the axis is perpendicular to its length and passing through one side, then about this axis moment of inertia will be 1/3 ml square. Now mass of the rod is m, but it is not a point mass, it is a distributed mass. Now think of it as if it is a point mass and put it somewhere here and claim that distance is k. If I put this entire mass as a point mass, then it can produce the same moment of inertia. Then what is the moment of inertia of this mass m? Mk square. So equate it. Mk square will be equal to 1/3 ml square, and immediately cancelling m, you can find that the distance should be L by root 3. So at a distance of L by root 3, you can put the entire mass of the rod as if it is a point mass to have the same moment of inertia. So then L by root 3 is the radius of gyration for this problem. And see, if you change the axis of rotation, moment of inertia will change. As a result, radius of gyration will also change. Okay. Now, I will ask you just one question. If you try to solve this question, you can learn many things about the mass moments and all these things. This question you can try for understanding properly the mass moments and what it says and all these things. Not particularly related to the exam, but for understanding of the concept properly, you can solve this problem. The problem is very interesting one. Always, suppose we are always familiar to this, that some old newspaper seller, when comes to our room to take old newspaper, they are taking the newspaper at a certain rate, say per kg equal to 10 rupees or thing. I will buy these old newspapers. Okay. So what he will bring with him? One beam balance. So he will take the beam balance like this, put some paper on a pen and some weight on the other pen, hold it like this such that the beam will be horizontal, and then declare that suppose this is 1 kg weight and some newspaper is there. When it will be horizontal, he said that okay fine, this one amount of paper will be 1 kg. Put it there. Then he took some other bunch of paper and again calculating this one and say that this is 1 kg. So again take 1 kg. So in this way, suppose he take 10 kg. 10 times measurement is required. He will take 10 kg and he will give you 10 into 10, that is 100 rupees. We are already familiar or accustomed to this process. Alright. Now, the situation is certainly different. Slightly different. The man is taking a beam, having a beam balance, but the beam balance fulcrum is not at the midpoint. It is at one side. It is at one side. That means whenever the beam will be horizontal, you cannot say that mass on pen 1 is equal to mass on pen 2. Now you cannot say. Even if the beam is horizontal, this length are different because that length should be at the midpoint. Now the man says that okay, fine, still give me those papers. I need those papers back. So you are saying that okay, I can give you the paper, but don't cheat me. So he is saying that okay fine, I will make this balance horizontal, and you are saying no. In that case, definitely either you will cheat cheat me or I will cheat you. I will not allow any kind of cheating. I will not cheat you, you should not cheat. Clear? Now, he is suggesting one procedure to you. Okay, fine. And remember, in this case, the newspaper buyer only has a weight, only one weight, and that is of 500 gram. Means, in a certain measurement, he can only measure 500 gram. He is suggesting that, okay, fine. So, first time, I will put 500 gram on the right pen and paper on the left pen and measure it by making the pen horizontal. Suppose in this case, this weight of the paper is actually greater than 500 gram. So he is actually gainer and you are the loser. And the man says that, okay, in the next time when I will draw one more measurement, I will put the 500 gram in this pen and the papers on this pen. Now, opposite will come because this will be less than 500. So you are the gainer and he is the loser. And in one measurement, two measurements successively, it should be 1 kg, 500 plus 500, because in the first measurement he is taking 600 gram, in the next measurement he is taking 400 gram. So now together in a two measurement it is already 500, already 1 kg. So there will be no profit or no loss to anyone. Then you are saying that, okay, I will agree in this method, but remember, you have to measure even number of times. You cannot say odd number of times I will measure and stop the measurement. I will provide the paper, but until even number of measurement you can stop. In an even number of measurement, you can stop at 2, 4, 6, anything such that no one can cheat the other. Okay? Perfectly? All of you are agreeing? Once you agree, remember, you will lose. After every even number of measurement, he is taking more than 1 kg, showing you 1 kg is taken, but he is actually taking more than 1 kg and he will pay you only for 1 kg and take some more than 1 kg. If you agree to the odd number of measurements, then actually you may be the gainer and he may be the gainer. So probability of getting profit or loss will be 50-50, 50%. But once you consider the most natural way to measure even number of times, you are always the loser and he is taking more than 1 kg in his two successive measurements. So you are always the loser. It can be proved by using this mass moment theorem only. If you try to solve this one, you can have a more clear concept on mass moment theory, how it works. See how it works. It seems that it is completely okay, even number of measurement, but it is at all not okay. This is the bill. Suppose fulcrum is here. This part is considered as X. This length is considered as X. This length is considered as Y. There is one pen. There is other pen. All pens are identical, massless. We consider this is the fulcrum. Okay. Now see what happens. First time you will put paper on this. Suppose these papers have mass M1 and on this you put a weight which is half kg. half kg weight is put here, and here some mass is there which is assumed to be m1. Beam is horizontal, means m1 into this perpendicular distance x mass moment, this should be equal to m2, this one is half into y in the first measurement. So you can write m1 equal to y by 2x. Next case, fulcrum is there, this is x, this is y. Now you put some paper here which has a mass of m2, and here you put half kg. The bands are interchanged. Then now apply the mass moment theorem. Half into x equal to m2 into y. So what is m2? X by 2y. So in two successive measurements, how many mass the man will take? m1 plus m2, and he is giving you for 500 plus 500, that is 1 kg's money. Now we have to check that whether m1 plus m2 is equal to 1 kg, or it is greater than 1 kg or less than 1 kg. If it is equal to 1 kg, then no problem. If it is less than 1 kg, then you are getting the money for 1 kg and giving less than 1 kg. And if it is m1 plus m2 greater than 1, then you are the loser. Check. m1 plus m2 minus 1 kg. Okay? Minus 1 kg. Then this result should be 0. If it is 0, then no problem. Then if it is positive, then m1 plus m2 is greater than 1 kg. So who is the loser? You. Check. What is m1? y by 2x. What is m2? Minus 1. Calculate. 2xy is the LCM. So it will be y square plus x square minus 2xy. You are the loser. X minus y whole square, x and y are not equal. So this whole square term is always positive. So x minus y whole square by 2xy is always positive. So we can argue that m1 plus m2 is greater than 1 kg. He is taking more mass and giving only the money for 1 kg. See how the mass moment theorem is utilized. A simple relation. Only mass into its perpendicular distance from the axis of rotation. So whenever a old newspaper seller buyer will come, say that first repair your beam balance and then I will sell. Before that I will not give you a single paper. Now, you have to remember two theorems regarding moment of inertia. One is perpendicular axis theorem and one is parallel axis theorem. Because there is some question in mock paper 1 which requires this concept of parallel axis theorem. suddenly three things are there, given four things are there, which are rolling and moving above the incline, up to a certain height. Since they are rolling, purely rolling, so they are rolling above the contact point. So the situation is like this one. So when they rolls and move up to a certain height, then it will stop and fall. Then from that you have to identify which type of thing is there. It is a disc, it is a sphere, it is a cylinder, and all these are given. Now to solve this problem, you require the concept of moment of inertia, but if you calculate the moment of inertia with respect to this will not work. Because the rotation is occurring, it is a pure rolling, so rotation is occurred with respect to this point. With respect to this point, it is rolling. So with respect to the center of mass axis, first you have to know the moment of inertia, that is half mr square. Then using parallel axis theorem, you have to find the moment of inertia about this axis of rotation and then apply for this. So then only you can solve this problem. So you have to learn the concept of parallel axis theorem and perpendicular axis theorem. Parallel axis theorem says that if there is a body I consider this is the center of mass axis, and with center of mass axis the body has a moment of inertia, suppose IC. Then about any other axis which is passing parallel to this axis, to any other point. About this point P, if the body has a moment of inertia IP and this distance is D, distance between these two axes is D, perpendicular distance, then IP can always be written as IC plus total mass of the body is considered m into d square. Means first you calculate the moment of inertia of the entire body with respect to the axis passing through center of mass. Then consider the entire mass of the body is concentrated at the center of mass, and then with respect to point P, this point mass is at a distance d, so its moment of inertia will be md square at this two. First you have to find the moment of inertia of the body about its center of mass, axis passing through center of mass. Then consider entire mass is like a point mass concentrated at C, center of mass. Then with respect to P, calculate its moment of inertia. It will be a point mass m at a distance d, so its moment of inertia will be md square at this two. You will get the moment of inertia about this parallel axis. This is the parallel axis theorem. To solve this problem, you require this one. So how? If we consider the axis is like this, so this is the axis passing through center of mass of this disc, and this is the axis that passes through point P. So with center of mass axis, this disc has a moment of inertia IC equal to half mr square. Then consider entire mass of the disc is concentrated at center of mass. Then what will be this distance? Radius. D is the radius for this disc. Then with respect to P, what is the moment of inertia of this point mass? M r square only. Okay. Then to find IP, you have to find IC plus M d square. But D is capital, D is R here. D is the axis are these two, like this. Parallel axis, distance between them is actually the radius. So I write md instead of md square, I write mr square. So first one is half mr square plus mr square. So total moment of inertia about this axis will be 3/2 mr square. 3/2 mr square. This you can find by parallel axis theorem. Then problem requires this calculation. And from that you have to identify that this one is a disk. Because from the problem you will get the moment of inertia, and moment of inertia will come out this value. So don't get confused. If moment of inertia comes this value, then this is the about the axis passing through the point of contact, not the axis passing through center of mass. Then using parallel axis theorem you can find the moment of inertia around center of mass and say that this one is a disk, not a cylinder, not a sphere. Okay. Another is perpendicular axis theorem. Means, suppose this one is the axis, this one is the body, and this body has mass m, suppose. And this is x-axis, this is y-axis, this is z-axis. Then about x-axis, this entire body has a moment of inertia ix. About y-axis, suppose it has a moment of inertia iy. Then about z-axis, it has the moment of inertia which is sum of the previous two. Iz will be equal to ix plus iy. All these theorems can be proved, but proof is not required for NEET. Competitive exam proof is not required. You can use this result directly to solve problems.